Hi, welcome to COMP501 Foundation of Programming. In this lecture, I will talk about the growth of a function and complexity. An algorithm with runtime complexity t sub n has what we call the lower and upper bound. The lower bound is a function that is less than or equal to the best case of the runtime complexity Tn for all value n greater than or equal to 1, and the upper bound is a function that is greater than or equal to the worst case of Tn for all value of n greater than or equal to 1. What that really means is the lower bound and the upper bound, um, the algorithm sit between the lower bound and the upper bound of these functions. So if the algorithm have the worst case 3n squared plus 10n plus 17, and the best case is 2n squared plus 5n plus 5, then the lower bound could be 2n squared, which 2n squared is always less than 2n squared plus 5n plus 5. And the upper bound could be 30n squared, where 30n squared always greater than the worst case for all n. The algorithm, which is these two here, sit between the upper and the lower bound. So if an algorithm best case runtime complexities are 4n plus 5, and the worst case runtime complexities are 8n squared plus 2n, which of the following is a lower bound for the algorithm? Which of the following is the upper bound for the algorithm? Notice that these are just choices. The lower bound and upper bound could be other answer, but for these given choices, what is the lower bound? What is the upper bound? Since the best case running time is 4n plus 5, the lower bound would be 2n. For all n, 2n would be less than 4n plus 5. And the upper bound, the upper bound would be, in this case, 10n squared. For all n, 10n squared would be greater than or equal to the worst case runtime of the algorithm, 8n squared plus 2n. And finally, let's talk about the asymptotic notation. In addition, the additional simplification can factor out the constant from a bounding function, leaving the function characterized as the algorithm growth rate, just like the big O notation. Just look at the trend. Instead of having some like a constant in front of the like a n square or n cube or n, so instead of saying an algorithm runtime have an upper bound of 30n squared, the algorithm could be described as worst case growth rate of n squared. So that's a three asymptotic notation. They are O, the big O. So the O notation provides the growth rate of the algorithm upper bound. Omega provides the growth rate of the algorithm lower bound. And theta provide the growth rate that is both upper and lower bound. So the O notation um, for the upper bound, that means for all n greater than or equal to 1, the runtime will be less than or equal to some constant time f for n. And for the omega, the worst case, the lower bound, for n greater than or equal to 1, Tn is greater than or equal to c times n f of n. And finally, for theta, this is the growth rate is both upper and lower bound, meaning Tn is O Fn and Tn is omega Fn. Let's look at a quick example here. Suppose Tn is 5n squared plus 2n plus 10. True or false? Tn is O(n) squared. Well, that's true, because you can find some constant such that you can find some constant such that 5n squared plus 2n plus 10 is less than or equal to some constant n squared times n squared. If the constant it's like I think constant 20 or something like that, this should be hold true. So because of that, this will be true. And is the Tn equal to omega n squared? That is 5n squared plus 2n plus 10 less than, I'm sorry, instead of less than, it's greater than equal to some constant time n squared. Well, if n is 1, this will be true, right? If n is, if c is 1, then this statement will be true. 5n squared plus 2n plus 10 is greater than that, so this is also true. Finally, if Tn is omega n squared, yes, that's true, because Tn is O(n) squared, and Tn is omega n squared, so Tn is theta n squared. So, in summary, you should know what is a big O notation. You should know how to determine the big O notation for an algorithm. How linear search work. What is a big O notation for the linear search? How binary search work. What is a big O notation for binary search? Know how to determine the algorithm efficiency. Know how to perform algorithm analysis, specifically the worst case scenario. And know the growth of the function and complexity. Know how to determine the asymptotic notation, the O notation, omega notation, and the theta notation. Thank you.